Alrighty, in our last video for the year, I want to look at 16.4, which is more applications of quadratics. We saw some in our last meeting, and I just want to go over a few more with you. The hardest part of these type of questions are just the setup. After that, you're just doing what we've been doing. So let's look at number one. It says in a right triangle, we talked about this in class, but in a right triangle, the hypotenuse is 10 feet. So remember, in a right triangle, you have a 90-degree angle, and this right here is called your hypotenuse, and it is equal to 10. One of the legs, so this is A and B, it doesn't matter which one you let be A or B, as long as it's this could be B and this could be A, but it doesn't matter. But it says one of the legs is 2 feet longer than the other. All right, so in that situation, if you just let A be A, then B must be A plus 2. Because then B would then be 2 feet longer than the other leg. And it's just asking you now, what are the lengths of the legs? So remember, in this situation, you can use A or you can use X, however you want to do it. But the equation is the A squared plus B squared equals C squared. So when I plug this in, I get A squared plus A plus 2 squared equals 10 squared. So I just plugged in what we just labeled everything as. Remember that A plus 2 squared is A plus 2 times A plus 2. So I have A squared. Oop. And then A times A is another A squared. A times 2 is 2A. 2 times A is 2A. And then 2 times 2 is 4. 10 squared is 100. So I'll combine like terms. So I get 2A squared plus 4A plus 4 equals 100. Then I'll subtract 100. So I get 2A squared plus 4A minus 96 equals 0. Now, it doesn't tell you what you have to solve by, so you can use the factoring technique, you can use the square root technique, you can use the completing the square technique, or you can even use the quadratic formula. My personal opinion is now that we know what the quadratic formula is, that is the easiest one to deal with, in my opinion. But if you have a different one, go with that one. So I'm going to kind of go with the quadratic formula. But before I even do that, I'm always going to look at, is there like a common factor? Is there a way to make my numbers smaller? And I see that 2, 4, and 96 are all divisible by 2. So that's what I'm going to do. I'm going to divide them all by 2. Even the equal 0, because if I do it on the left, I have to do it on the right. So 2A squared divided by 2 gives me A squared. 4A divided by 2 gives me 2A. 96 divided by 2 gives me 48. And 0 divided by 2 gives me 0. Now I can play the A equals 1, B equals 2, and C equals negative 48. Remember, the formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in this case, I'll get negative 2 plus or minus 2 squared minus 4 times 1 times negative 48, divided by 2 times 1. That gives me negative 2 plus or minus 2 squared, which is 4. 4 times 1, which is 4. 4 times negative 48 will give me a plus. Okay, so that'd be 48, 96. 96 plus 96 would be almost 200 minus 8. So that'd be 192. And then 2 times 1 is 2. And then we get negative 2 plus or minus 196 divided by 2. 196, I believe, is 14. So that's plus or minus 14 divided by 2. We haven't gotten a C one that comes out nice and clean if it could have been factored. So in this situation, this becomes negative 2 plus 14 divided by 2. And this would be negative 2 minus 14 divided by 2. So negative 2 plus 14 is 12 divided by 2, which gives me 6. Negative 2 minus 14 is negative 16 divided by 2, which is negative 8. Now remember, this is a real world problem, so negative length is not possible. So that means 6 would be my answer for A. So one leg is 6, and the other is 8 because it was 2 more than the smaller one. All right, so again, maybe factoring could have been the easier method here. But again, every process will work. But factoring doesn't always work. So my go-to is I just want a method that will always work. So I'm gonna work on memorizing everything. Let's look at another type. It says working together, Henry and his son Bill can paint one room in 2 hours. When Bill paints a room of the same size by himself, he takes 3 hours longer than his father. How long does it take for his father to paint a room? So this goes back to the rational expression one. This is a great review here, but so working together, um, so together they can get one room done in 2 hours. When Bill paints a room, so here's Bill, of the same size by himself, he takes 3 hours longer than his father. So for him to complete a job, he takes whatever amount of time his father does, and it takes him 3 hours longer. So father can do one job in so much time, and then Bill can do it 3 hours longer. So then together, how long does it take for the father to paint a room of this size? So then I can add these together. And so if you recall, to actually work these out, I'm going to multiply by the common denominators. So that's going to be the 2, the x plus 3, and the x. So this goes into all of them. So therefore I get 2x plus 3 times x times 1. So that's going to just be over 2. And then I get 2x plus 3 times x over x plus 3 plus 2 times x plus 3 times x over x. This will cancel, and this will cancel. So now I have x plus 3 times x, 2 times x, and 2 times x plus 3. So now I just need to distribute out. So x times x is x squared. X times 3 is 3x. 2 times x is just 2x. And then another 2x plus 6. I'm going to combine like terms. So that gives me 4x plus 6. And I'm going to move everything over. So minus 4x, minus 4x, minus 6, minus 6. So I get x squared plus 3x minus 4x is actually minus x minus 6. And again, any process will work here. I'm going to go with factoring on this one. So that'd be x and x. I'm thinking 2 and 3. I'm thinking negative 3, positive 2 equals 0. When I set these equal to 0, I get x plus 2 equals 0 and x minus 3 equals 0. So if I subtract 2, I get x equals negative 2. And if I add 3, I get x equals 3. Now you can't get a job done in negative time. So therefore 3 must be my answer. And since I'm just looking for the father, then I know that the father can paint a room in 3 hours by himself. All right, let's look at another type. In this example here, it says a motorboat traveled 10 miles an hour in still water. The boat takes 4 hours longer to travel 48 miles going upstream than it does to travel 24 miles going downstream. So we're going to find the rate of this current. So the best way to approach this is remember that time is equal to distance over rate. And so we will say upstream and downstream So the distance of upstream, the boat takes 4 hours longer to travel 48 miles upstream. So we got 48 miles. And so if he's traveling at 10 miles an hour, that's his rate of his boat. It's going to be deducted by however much the current he's fighting. And it takes him, so this is distance, rate, and time. And then it takes him, we'll bring that part in later. So then to go downstream, it's 24 miles an hour. And this time he's going to go with the current. So to find the time here, it's distance divided by rate. So it's going to be 48 over 10 minus x, and this would be 24 over 10 plus x. And we know the difference is 4 hours. So it says the boat takes 4 hours longer to travel 48 miles upstream than it does to travel 24 miles. So that would mean that this guy, whatever this time is, minus whatever this time is, will be 4 hours. Now, with this, we can then multiply by our denominators of 10 minus x and 10 plus x to everything. So then I get 10 minus x times 10 plus x times 48 divided by 10 minus x minus 24. Oh, I guess, hold on. We'll do 10 minus x times 10 plus x times 24 over 10 plus x equals 4 times 10 minus x times 10 plus x. So then this would cancel and this one would cancel. So I'll go ahead and distribute. So that's going to be 480 plus 48x. And then this negative and this 24 will both be going in at the same time. So that would make that negative 240 and a positive 24x. This right here is going to be 10 times 10, which is 100. 10 times x, which is 10x. Negative x gives me negative 10x, and then negative x squared. I'm going to kind of combine like terms as best as I can. So that's going to be 480 minus 240 would be 240. 48 plus 24 would be 70x. Nope, I lied. 72 equals. Then this would be 4 times those would cancel. So I'd get 100 minus x squared. Distribute that out. So that gives me 400 minus 4x squared. I got 240 plus 72x. Continuing this on. So I'm going to start back up here. So 240 plus 72x equals 400 minus 4x squared. I'm going to move everything to the left. So I'm going to add 4x squared. Subtract 400. So I get 4x squared plus 72x. And then 240 minus 400 is 160. And then I do notice that they are all divisible by 4. So I'm going to divide everything by 4 to make my number smaller. So this is x squared. 4 goes to 72. I want to say 18 times, but let me just check it real quick. Yep, 18 times. And then 4 goes to 160, 40 times. And so now I can do my factoring techniques here. Two things that multiply to 40 but add up to 18. I instantly go to 5 and 8, but that's 13. Oh, how about this? 20 and 2 will make this one positive, this one negative. So when I set these equal to 0, I get x equals negative 20, and this would be x equals 2. It can't be negative 20, so it has to be 2. So that would mean that my current of the stream is 2 miles per hour. All right, so and we've seen most of all of these before, so this is a great review to see all the application problems again. Let's look at another one. This one says a bullet is fired straight up from the ground level with a muzzle velocity of 480 feet per second. When will the bullet hit the ground? All right, so in this one here, you have to be given this equation. So it's usually always given to you, but it's H equals negative 16t squared plus V naught times t plus H naught. That just means the initial velocity. This one just means the initial height. So you're given a bullet is fired straight up from the ground level with a muzzle velocity of 480 feet per second. So that's your initial velocity. So that means your VO or V naught is 480 feet per second. And then it said, when will the bullet hit the ground? All right, so and it says from the ground level. So that means that my H naught would be 0 feet. So I'm going to plug in. I'm trying to figure out when it's going to hit the ground at 0. So when it hits the ground again, my height from the ground would be 0. So that means this would be 0. So that means I have 0 equals negative 16t squared because I don't know the time. I'm trying to find out when it will. Plus 480t plus 0. So when I do that, that pretty much goes away. So what I'm going to do is does 16 go into 480? Let's see. So 480 divided by 16. It does. So I'm actually going to divide everything by negative 16. So I don't want to have to deal with negatives anymore. So that will just become 0. That will just become t squared. And then this will now become minus 30t. Then I'll factor out t. So that's going to be t minus 30 equal to 0. So I get t equals 0, which makes sense because when I shot the gun, it was 0 seconds. And then I get t minus 30 equals 0. So when I add 30 to both sides, the bullet will hit the ground again in 30 seconds, since that's what the units were given to me. So that's that part A here. Part B, it says, when will the bullet be 2,000 feet above the ground? So this is the same concept, but now my H is 2,000. So then I'm going to do the same math. So I get 2,000 equals negative 16t squared plus 480t plus 0. Once again, I don't really need that part. But I do need to get all of this moved over. So I'm actually going to add 16t squared and minus 4080t. Because again, I just don't like dealing with negatives if I don't have to. So I get 16t squared minus 480t plus 2000 equals 0. I know 16 goes into 480, but does it go into 2000? It does. So I'm going to divide everything by 16 to make my numbers even smaller. So I get t squared minus 30t plus 125 equals 0. So I'll try my factoring techniques in this example. So t, two things that multiply to 125 is 15 and 15. Nope, I lied. 15 and 5, I believe. No, 25 and 5. That's a better one. 25 and 5 gives me 125. And they'll both be negative because that will perfect. So then I get t minus 25 equals 0 and t minus 5 equals 0. So then t would equal 25 and t would equal 5. In this example, it actually is going to hit 2,000 feet in multiple positions. So at 25 seconds and at 5 seconds, because you got to realize it's going to hit that threshold and then it's going to come back down. So in 5 seconds, that bullet will be 2,000 feet up in the air. And then after another 20 seconds, it will come back down to 2,000 feet up in the air. All right, let's look at another type. Let's look at number 5. 5 says a square piece of cardboard has a small square 1 inch by 1 inch cut from each corner. So here we go. This is the most famous question when it comes to quadratics. I think I've taught this in every type of math class I have taught at some point. But you have a piece of paper and we're going to cut a 1 inch by 1 inch corner from each one. Just showing that we're going to pretend all of those are the same measurements. So I say again, a square piece of cardboard has a small square 1 inch by 1 inch cut from each corner. The edges are then folded up from a form to form a box with a volume of 64. So it tells us our volume is 64. What are the dimensions of the box? Oh, good piece to say. It's a square piece. So that means that this all have to be the same length. So here we go. So when we look at this, we don't know the length of this square, but let's call it x. To find volume, it is length times width times height. So in this case, I have x times the height. Well, if these are all 1 inches, that means the height of this box, when I fold this section up, will be 1 inch as well. All right, so in this example here, at some point we have to decide what we want this to be. If this, we can let this whole thing be x, and we can take one away from it, or we can just let this be x since they all have to be the same length, and then we know the height is 1. I'm curious if we'll get a different answer. So I'm going to go this approach, and I want to go the other approach because I am curious now if the other approach is this one. So if this is x, if this whole thing is x, then this whole thing would be x minus 2. So the other approach is x minus 2 times x minus 2 times 1. I feel that we'll get the same answer. Let's see. So in this case, I get so I'll get 64 equals x squared. And then if I take the square root of both sides, I get plus or minus 8 equals x. I can't have negative measurements. So I think my x is going to be, I think my dimension of my square is going to be 8. If we go this approach, let's see if we get the same thing. So we get x squared minus 2x plus 4, and then 1 times all that. So that's x squared. Oh, equals 64. Equals 64. Then that'd be minus 4x plus 4 equals 64. Then I'll subtract 64. And then I'd get x squared minus 4x minus 60 equals 0. See, we could do 6 and 10. That'd be negative, and that would have to be positive. So that'd be x plus 6 equals 0, x minus 10 equals 0. So that'd be x equals -6, and this would be x equals 10. Again, can't have measurement. Can't have positive numbers, but then you get x equals 10. So when you're looking for the dimensions of what the original question, what are the dimensions of the box? Then I would have to come over here and do, well, 10 minus 2 gives me 8. So you get the same answer, but I just feel like this process is just a little bit easier of straightforwardness. So the dimensions here, then again, would just be 8 by 8 by 1. But you can get it the same approach. So I'll let you kind of decide. This is kind of how the book does it. This was my thought process. But in different situations can be different things. Because if I would have told you, hey, this is 12 and this is 13, then I would have to subtract 2 to find the new dimensions and go from there. Or if I just gave you this one and gave you like an equation for this one, it'd be the same process. So I just guess it just really depends on the situation. But again, this would be the process I would have taken on it versus what your book did. All right, let's look at another one. Let's look at 6. 6 says a Major League Baseball field is the shape of a square. We got a square. We'll pretend it's a square with sides of 90 feet. So that means all of these are the same. What is the distance to the nearest tenth of a foot the catcher must throw from home plate to second base? So let's pretend this is home. This would be first, second, third. So what we're trying to do is determine what is this distance right here. So that makes this a 90 degree. And since this is both 90, this is our Pythagorean theorem question. So this would be 90 squared plus 90 squared equals c squared, because again, it comes from a squared plus b squared equals c squared. And this is your c, and this is your a, and this is your b. Again, that part doesn't matter. So 90 squared is, I'm pretty sure, 8,100. Yep. So this gives me 8,100 here plus 8,100 here equals c squared. If we add these two up, we get 16,200 equals c squared. Then I'm going to take the square root. And again, because I know it has to be a positive, I'm not going to stress about that plus or minus. And I get 127 point, well, it said to the nearest tenth, so that'd be 0.3. And this was measured in feet, so this would be, it's about 127.3 feet that catcher has to throw to second base to get that guy out. All right. That's another approach. So let's look at number 7. Number 7 says the members and family of a curling team were going to the national championship, and we're going to rent a bus to drive them there at a total cost of $800, which was to be divided equally among the members. At the last minute, 5 members had an emergency and could not attend. The cost to the remaining members increased by $8. How many members attended the national championship? All right, so the members and family of a curling team were going to the national championship and we're going to rent a bus and to drive them, and the total cost would have been $800. So that's the initial cost. We're gonna have to do this twice. So initially, we would have so many members, divide that by 800, and then that's how much each cost was going, or that's how much each member would have paid. But then we come to find out that 5 members left. So now whatever this was, I had to take 5 from it. And again, I don't know how many members there are, but when I do take the difference of these two, the total increase was $8. So from there, I'm back to figuring out what I need to multiply by. So I'm going to multiply everything by the denominator. So I have an x minus 5. Ooh, that's an 8. And an x. This gives me 800 x minus 5 x over x minus 5 minus 800 x minus 5, x over x equals 8 times x minus 5 times x. That would cancel. That would cancel. Go ahead and distribute. So that would give me 800x. Remember, this is going to be attached to this number. So when I distribute, this becomes minus 800x. And then I want to say that's 4,000. Let's see. Yep, so that'd give me minus 4,000. And then I'm going to distribute and distribute. So that'd give me 8x squared minus 40x. I'm actually going to combine. So that's going to, oh, that actually cancel each other out. So then I'm just going to add the 4,000 over because again, I don't want to have to deal with negatives. And so here, I believe everything can be divisible by 8. I want to say that's 500. So let's see. So 4,000 divided by 8 is 500. Ooh, okay, so if we do this factoring thing here, so we get x, two things that multiply to 500. I go to 50 and 10, but that's not 5 difference. Do, do, do. Let's see, what's 500 divided by 25? Oh, there you go, 25 and 20. And so that would then make this a negative and this one a positive. So that means that x would equal 25 and x would equal negative 20. Well, you can't have negative people. So I must have originally had 25 people. And I believe that's about all the different type of problems I saw on y'all's homework. So that should give you some good examples there. As always, if you have any questions, feel free to email me. Other than that, that's the last video of the semester. So I would like to say see you next time, but next time I see you will be a final exam time. Other than that, good luck. Happy studying.